Good evening, everyone. My name is Richard Dunn, and I am here for CIT 381 for my presentation of the results of my research project on decision analysis. And I want to take a little bit of time just to share what I've learned about decision analysis and some of the methods that I have learned about in order to make decisions. And let's start by talking a little bit about what decision analysis actually is. Decision analysis is the discipline comprising the philosophy, theory, methodology, and professional practice necessary to address important decisions in a formal manner. Decision analysis includes many procedures, methods, and tools for identifying, clearly representing, and formally assessing important aspects of a decision, for prescribing a recommended course of action by applying the maximum expected utility action axiom to a well-formed representation of the decision, and for translating the formal representation of a decision and its corresponding recommendation into insight for the decision maker and other stakeholders. Now, let's go ahead and translate that into English. Decision analysis is the process of identifying important information used in making a decision and then conveying that information to the decision maker and other important parties, like, for example, shareholders. So I want to take a few minutes and just talk for a few minutes about the different kinds of decision making processes that I have learned about while I've been researching this. And the first one I want to talk about is causal modeling. Causal modeling refers to techniques for inferring from data the effects of actions on outcomes. It's distinct from regression analysis, which we've learned about previously in this class, which has no notion of causality. Regression analysis doesn't take causality into effect. Causal models are particularly of interest to financial services, retail, marketing, and healthcare applications. So when we're talking about this, basically the questions that we're asking are, does a treatment affect the outcome? Does a treatment affect the outcome differently for different customer types? And can we predict sensitivities of customers with respect to treatments, or rank order customers according to these sensitivities? So, for example, if we were trying out a new drug, if we were in the pharmaceutical industry, we could look at the way that a drug affects the person and say, does this drug affect the illness that we're trying to prevent or cure? Does the treatment affect the outcome differently for different customer types? So, for example, does this drug affect women differently than men? Does it affect Black people differently than white people? And then from there, can we predict the sensitivities of these various customers or patients with respect to treatments, or rank them according to their sensitivities? Can we say, it's going to affect this, African American woman differently than this Caucasian man or this Asian woman, or based, kind of create a model based on those different variables that are in play. Another good example would be in 2008 with the housing market. When the housing market was going on downhill, there were different programs, there were different stimulus packages or loan modifications or things like that that could be brought into play. And at the time, I was working in the mortgage industry, and I could look at different customers and kind of get an idea based on certain models what was going to be better able to assist them with keeping their homes during that terrible, rough time. Let's talk a little bit about pattern recognition. Pattern recognition can be defined as the categorization of input data into identifiable classes via the extraction of significant features or attributes of the data from a background of irrelevant data. So basically, we're going to look at a whole mess of data. We're going to pick out patterns that are relevant, and we're going to use those to extrapolate further what could happen next. The basic components of pattern recognition are feature extraction and classification. The feature extraction is the process of converting potentially huge amounts of raw data into a sufficient, manageable vector of features via data compression and dimensionality reduction techniques. Now, that's a big word for saying we're going to look for patterns in a whole lot of data and kind of break it down. What I saw as an example of pattern recognition might be the sentiment analysis project that we did in week 4. We took a number of movie reviews that were broken down And we determined whether certain words were positive or negative, and based on those words appearing in another review, we could make a determination whether that review was going to be largely positive or negative. Now, looking forward, what I could see is that this would be good for the upcoming game theory project, particularly for paper, rock, scissors. If I am playing paper, rock, scissors against somebody who always picks whatever I did last, I can identify that pattern and I can adjust accordingly. And I can do the same thing with an AI. I could, look at someone who always picks rock or picks rock 2 times and then picks scissors. These are identifiable patterns that we can pick out from the massive data of a game of paper, rock, scissors. And from there, we can make a determination as to what's going to happen next and plan our next move accordingly. So that's pattern recognition. And the last one I want to talk about is survival analysis. Now, I mentioned in my initial prospective for this assignment that my wife has been watching a lot of Shark Tank, and I find that show fascinating as to how they make the various decisions, the various evaluations that they make on their companies and things like that. And something that they'll talk about is whether or not a company is going to go to zero, whether or not a company is going to survive without an investor or with an investor, what the outcome of a company looks like it's going to be. And that is kind of what I thought about as I read about survival analysis. Survival analysis is a collection of statistical methods where the outcome variable is the time until an event occurs. So in the case of what I'm talking about, the time until a company goes to zero and goes completely bankrupt. The event of interest may be death or relapse from remission in epidemiology, structural failure of a component in manufacturing reliability test, attrition of a bank card holder or a mortgage prepayment if you're working for a bank, or, like I said before, the time until a company goes completely bankrupt. That time could be days, months, years from the start of the observation period until the event of interest occurs. So this is now I said earlier, survival analysis is a collection of methods. This is one of them. This is what's called a survival function. The lowercase t is an amount of time. T is a random variable denoting the time of death. PR stands for probability, so this does take some degree of randomness into play. The survival function is the probability that the time of death is later than the specified time t. The survival function, in this case, is also called the survivor function or survivorship function. That's mostly for biological survival, and the reliability function in mechanical survival. And in that case, the reliability function is RT. So usually what we're going to assume is S0 equals 1. It could be less than 1 if there is the possibility of imminent death or failure. So basically, we would work through this equation, and I will admit it's a little bit over my head, but to make a determination of how quickly an event is going to occur, and then based on that, make a determination of what we're going to do going forward. In the case of my Shark Tank example, they may say, I could invest my money in this, but it's probably not going to last more than a year or so. And I've heard the investors on Shark Tank talk about that. So those are kind of the 3 decision processes that I researched while I was in this process. I want to thank you for your time and your attention during this presentation. I did include my sources on this. And again, my name is Richard Dunn. Thank you for your time.